Yeah. So the stoichiometric ratio is 1:1. That means 1 mole of HCl will react with 1 mole of ethanoic acid. And then since, oh, no, ethanoic, what is the mistake I'm making? Why? Lynn says that she does not think that they mix together because of what, Lynn?
They are measured for the pH.
Okay, for the pH only. Noor, what was the mistake I was making? Ethanoic acid and hydrochloric acid react 1:1. Is that true?
I thought
No?
we are doing it separately, like HCl first and then ethanoic acid.
Okay, yeah, Eric says that she doesn't think that will mix together.
We don't mix the acid.
The thing is, I was confusing ethanoic acid as sodium hydroxide anyway, so, or HCl as sodium hydroxide, because both of them are acid, right? So there is no question of having a reaction between them. Yes, but anyway, ethanoic acid and sodium hydroxide, if there were, they would react 1:1. So anyway, you know what is the stoichiometric ratio? We have already said. I mean, we already discussed in the lecture slide. So you know that stoichiometric ratio is a refreshment for you probably. So now, yeah, now we will be doing that. Measuring or determining the pH. Not measuring, we cannot measure the pH, we only can determine because this is the intrinsic value for this depending on what the concentration we are having. And these are the pH meter. Do I need to do the calibration? No need, just. Okay. So for this pH meter, we have to use both, right? Both together inside. Okay. So this is the pH meter. We will be using it to determine the pH of the solution that is given as per the methodology says for this experiment. And later on, and then it will, for here, we will see, can you cancel these values? These values was given previously, and we will not use this value for this SEM. We will use what we get. I mean, this was fabricated, so today we will get whatever we get from the lab or from the experiment. We will find the pH, and from that pH, we will find the hydronium ion concentration. How do you find it? Exactly, that is called anti-log or anti-log, however you say. So 10 powered negative pH is the hydronium ion concentration or hydrogen ion concentration from this way. So from here, we'll see what is the pH concentration or pH value for acid, strong acid or strong base or strong acid and weak acid and whatever. And then here, the initial, we have to come up with this following ICE table. Vanessa, don't help me, but I like to ask question. After that, I'm going to ask Lynn. So here it says that CH3COOH, that is the ethanoic acid, isn't it? Why no HCl here? Only for ethanoic acid, the table. Can we make an ICE table for HCl as well? HCl, yeah. Lynn? Any? Why? Which one? Ah, yeah, great. So HCl is a strong acid, right? What does a strong acid mean? No, what does strong acid mean? Yes, this is that will give ionization, I mean, dissociate in the water fully. So HCl will not, we cannot produce the ICE table because they will not reach to a equilibrium. They will totally dissociate, right? So that is why CH3COOH is a weak acid. We can find the IC table. We have to find out the concentration, and at the after some time, initial concentration we will find. Initial concentration, how do you find the initial concentration? Is given. right? 0.1 or 0.2, whatever is given there, 0.1, 1 milliliter, 1 molar or 0.1 molar. And then after some time, we measure, detect the pH. We find the concentration in the equilibrium concentration that is considered, and that will be used for the equilibrium concentration. So the changes occur, we can find out from the calculation that we have done it before, right? This type of IC table, we have done it before in the tutorial in the lab. And the second part for this lab today is second part is to find out the buffer solution. What is buffer solution? Eric, what is the buffer solution?
A solution that stops the solution from changing the pH level to a certain degree.
Yes, exactly. Thank you. So the solution that helps to withhold the action or what do you call it? Action of adding more acid or base to it, a small amount of acid base to it. So we will see it how the pH, the buffer solution resist the changes of adding acid and base to it, right? So first of all, what should we do for the experiment 1? Anyone? What should we be doing?
If it has been done,
Yeah.
we need to rinse the apparatus first.
Yes. So rinse the apparatus with distilled water, and then we proceed according to the procedure that we dilute the hydrochloric acid, and then we determine the pH of that. And so on. After the pH probe, repeat with ethanoic acid as well. We will first we will do the hydrochloric. It doesn't matter. You want to do with hydrochloric acid first or the CH3COOH or ethanoic acid first. It's up to you. But the thing is, we need to dilute it first. So how do we dilute it? 1:10, right? Yeah. So you take 10 milliliter and dilute to 100 milliliter in the volumetric. This is a volumetric flask, by the way, right? So, or round bottom flask, some call round bottom. So yeah, that's it. So I think we can start now. Online, those are at online. On any question do you have? Yes. Guys, can you see Vanessa? She will be your demonstrator today. Next lab, I will choose someone else. Rinsing means not taking too much of water, just a little bit, and then, yeah, making sure that it touches everywhere. No, not like that. You need to take the cap. Yep. And then, yeah, do it like this so that it touches everywhere. All right? Touches everywhere like this few times and then throw. I think I should take the gloves for myself as well. Huh? This is just a distilled water?
Yeah, I mean like, it's just distilled water, it won't corrode your skin, right?
No, it's not. But the safety procedure is we should be using gloves. The water liquid. The soaps. Your gloves, can I see? I think you need to clean your gloves first. Otherwise. And then you go like this so that it touches everywhere, like this, and yeah. And try to rinse up or discard the water as much as possible. How is it going, Lynn?
So it's like bubbly.
Oh, I think previously those who used the soap, they did not clean it properly. You see, that's why I say that always clean it for your friends. That is just soap. So, and you are having the gloves on. So hopefully there will be no much problem. And for the reagents and chemicals, please follow this whiteboard. Fume hood 3 is your ethanoic acid or acetic acid and hydrochloric acid. Fume hood 5 is sodium hydroxide and sodium acetate. Fume hood 6 is ethanoic acid, 0.1 molar, 0.1 hydrochloric acid, waste bottle. So do not dispose anything in the sink. Please dispose all of the waste, part A and part B, into the waste bottle that is in fume hood 6. There. Okay? So do not throw anything down the sink.
Finish rinsing, we just take the beaker and go and get the chemicals, right?
Yeah.
The beaker don't need to rinse, right?
It's standard that you should rinse it. But yeah, I mean, just take 3 or 4 beakers. What? Huh? Oh, sticker. Here. The stickers are here. Yeah. This is finished already. I don't know you guys can see or not. You don't need to take a lot, just a little bit, because you need to just take 10 milliliter from here. Yeah, enough.
I thought when measuring using this is less accurate.
Yeah, but afterwards you have to take with the pipette to the volumetric flask. So just take maybe 10, 15, 20 milliliter should be okay. Yeah. So just take 15 to 20 milliliter. Have you labeled it? No? Okay. Otherwise it will be confusing. I mean, you will confuse it. There? The pipette stand. There is a pipette stand there. Here is given to you is 10 milliliter here. Did you rinse?
Yeah.
Okay. Make sure that there is no excess of water. It's better that you rinse it with the acid when you take it. So let me show. Did you rinse? Okay. Okay, this is enough. Just I'm taking 1 milliliter of it, and then I'm trying to take it off. So 10 milliliter means you have to take until this mark, there's 10 written, the mark there, and then discard all of it.
Cut all of it to the volumetric flask, right?
Yeah. So you need to label as well here which one is what. Otherwise you will miss. You can take first and then.
Later after I pipette the HCl into there, do I need to also rinse it with this?
You have to rinse it with the water first.
Rinse with distilled water.
Distilled water, ideally, or you can just rinse it with this distilled water. Yeah, distilled water, and then you have to rinse it with this acetic acid. Oh, the light is not working properly. You have to be.
Slightly.
No. Is it touching the? I mean, meniscus touching the lower? Can I see? No, a little bit. You see. Yeah. Put your eyes together, like from. I mean, how do we see that it is the level that your eyes is looking through this line and going through that line? So that means my eyes is on the level. And I see that the surface of the liquid is lower than that. So it's not accurate. I have to take a bit more. It's a little bit more. Don't worry. You can always release it. Yeah, now you see that the meniscus is touching. So this is the 10 milliliter. Okay, take it now. Do we know that we will have an exam, final exam 1 next week? Does everybody know?
That is first.
Sorry?
That is first. Oh, yes, I got
21st?
No, I am depressed because I have a long assignment.
This is the sign of that you are finishing your semester.
Yeah, I know.
Yes, after that you are so free. Now, guys, you can see Noor is doing her, wait, yeah, is it? Can you see? Yes. Noor is doing her work. So Noor for some time. Be careful with the probe because the probe is very sensitive. Okay. So what are you doing, Noor? HCl? Okay. Hold on. Just one trick I show you. Lynn, come here. Vanessa, come here. One trick I show you. That at the end, there is a little bit, right? At the end, there will be a little bit of liquid here, and it is, so it is very hard to get it out from it. Don't force it to take out because it is the remaining or the deduction of the meniscus that we just took. It was concave, right? The shape. So the meniscus, we take it. And we do not need to force it. Do not pump it up, out, or blow it, or shake it too much. Just do one thing. Take your finger like this, and then put it here on there, and then just gently press it. It will come, whatever it's supposed to come. And that's it. Do not shake it, do not take it, try to take it out, anything, just it. That's it. Okay? So it is considered that it is 10 milliliter dispatch there. I think I should wash it a bit. HCl. See?
Percentage on the upcoming exam.
Hello, yeah, who is it? I cannot see that.
Yeah, I'm saying what's the percentage on the upcoming exam?
Come again, please. Sorry.
The percentage on the test.
Percentage of?
The test next week.
Oh, the 25% test. It is.
Then we have another test, right? After that test. Yeah.
Yes. So the final exam that we already discussed during the, the beginning of the semester, that final exam has been divided into 2 parts. So both part each will have 25%. And actually the exam, the format of the test, final exam 1, is very similar to the mid-semester test. So you have the structured question, and you also have the MCQ. And you have 2 hours to finish all those things. Yeah. So once you have finished your structured question, then please proceed for the MCQ. MCQ anyway will be open 1 hour after the structured question has opened. Started. Yeah. What happened? Okay, there is a good. Yeah, that is good thing. Come, I'll show you. So this is from Lynn. Can you, I don't know whether you can see. Yeah. So this is for Lynn. This is the mark was supposed to be, she has to fill up this part, but a little bit here. So she's asking, can we just take it? We can, of course, take it, but the problem is we do not know how many times we have diluted it. Is it 11 times, 10.5 times? We do not know. Until this mark, we know this is 100. But here, we do not know it is 101, 102, 103, 105. We do not know how many milliliters. So, yeah, unfortunately, we have to do again. Same thing for you too?
I think
No.
No,
You're
it was
okay.
done just now, but then I plugged it out.
No, you cannot. So you have already discarded the HCl molecule as well, right? So you have to redo.
But I thought it was hard enough.
No, you have to redo whole thing, yes.
So I throw it down the sink.
No, there, in that white container there in tube number 6.
I'm having second thoughts on how to do this.
Yep.
Just keep putting until
Until, come here. Okay, Vanessa is doing now. So keep pouring the water until it reaches to this part probably.
so it doesn't reach here.
No, don't put until here, put here until here, and then, oh, hold on. So here, it reaches almost to the collar, right? Now I have to make sure that I mix it properly. Well, where is the cap? Give me the cap. I actually need 2 hands, but since I'm holding the phone, no, it's okay. So what we will do is, with the help of 2 hands, we should make sure that it mixes well, okay? So like this, actually, with 2 hands, we will make this to make sure that it mixes well, everything. And then, here, we will try to add more water from the distilled water. Uh-oh, is it too hard? Twist it like a cap, yeah. And then hold it. And then add the water until this part. Don't make it full. More, a bit more. More, a bit more. Okay. Now you add with the, take a dropper and then drop by drop add the water. Take a dropper from there. Or you can also use the pipette, but pipette you need to wash it, so take a dropper better. Yeah? Yeah, I mean, have to put the cap on. Yeah. This solution. Yeah, sure. I will tell them later on. Yeah, no problem. Okay, so in that white box. Yeah. So these 3 droppers I'm giving to 3 of you. You need to wash the dropper first. Distilled water. You here you fill it up, then fill until here with the water, and then use the dropper to drop.
Hello, sir. We cannot see, sir.
Really? Okay.
Yeah.
Hold on. Yeah. Hello. I cannot see. Is Vanessa here?
Yeah, I can.
Can you see now?
Yeah.
Yeah, she's adding water drop by drop to make sure it is better to put it on the table so that you get a perfect level. Otherwise, you keep it in your hand and don't put this here. It's so precarious.
Until the meniscus level touch it.
You will. Yeah, meniscus only that. Yeah, you need another 2-3 drops probably. 1, 2, 3. Another 1 drop. 1 more. Yeah, done. So we can see that the meniscus is touching the line now. So it is considered done. It is 100 milliliter. All right, good. So you need to do it for the same thing for ethanoic acid, right? This 3COOH.
So if I already washed that with distilled water, then.
Have you already?
Yeah.
Okay. So the thing is, one just last thing that you need to do it, invert it few times, so to make sure that it mixes well, everything. Okay. Yep. So take 10 milliliter, and then the same way you have to dilute it. Is it? I don't know. I cannot see from here. A little bit more, I think. 0.05 maybe. Not. Yeah, it's too much. Now you need to, again. Yeah, now it's okay. Straight it. A bit more actually. It take more and then try to reduce it. That is easier. Take more. Yeah, now it try to reduce it. Yeah, it's good. Just press up on your thumb or your finger, yeah. Okay, it's not coming out anything, so it should be all right. Okay. How is it? Have you finished already? Have you mixed it well? I mean, put the cap on, and you need to swirl it for some time, 2 or 3 times, invert it a few times so that it, that it mixes well everywhere, the HCl and water molecule together. Okay, so hopefully it is nicely mixed. Now do it for the same for ethanoic acid. Yeah, it's considered mixed because they are readily mixed with water. So we do not have to do it vigorously, but yeah, to some extent it will be, we shake it so that it mixes.
So fill it until here.
Yeah.
After that.
Yeah. The bubbles are coming because you don't have enough, so you can tilt a bit and then, yeah, take from here. Not enough because you're, yeah. Yeah, so try to reduce it. You have to keep your eyes at the level, yeah, not like this, not tilt your head, yeah, like that. Yep. Few drops more. 1, 2, another one. Yeah, enough. No, another one more drop. One more drop. Yep, good. So now give a gentle shake. How is it, Lynn? Done both? Okay. It's so dangerous to put here, move it a bit here, like this. Okay, so now we do not need these beakers anymore. I mean, with this, so discard this thing, and later on we will need this beaker. So we will be using this beaker, just discard it and then wash it with water. We have just 1 hour to go, so need to do it faster. No. If you tilt it, the water is not going to go more, and you need another bottle actually. Later, please refill the bottle before you go. So here, ideally we should wash all the way and then pour the water. So shake it like this. And you see that water is mixed. Now use the dropper to drop wise. Make the, yeah. To the top, yeah. Did you wash the glass? I mean the volumetric flask? Probably it is not very clean. You can see the oily substance. Anyway, so try to do. You have to bring your eyes to the level. Yeah, done? So, have you washed this?
Yeah.
Now, with this? Yeah, put the water. Okay.
So last time in high school, we don't actually have like a waste bottle to pour away the hazardous waste.
Yeah, because now the hazardous waste, because the water, every year, Swinburne needs to treat the water and it costs a lot. We cannot just discard it to the main source. We have to treat the water, and then that's why we try to reduce it, because it's the environmental issue. Okay, hold on. Let it be dry a bit, or the water may be scattered.
So I just wait for them.
Yeah.
What's the next label that I have to put?
Sorry?
What's the next label I have to put?
No, there is no next level. No need to put the next level now. Later. These two, you don't need it anymore. So what you do is just discard this thing in that waste bottle, and then wash it with the tap water, then rinse it with the distilled water. Go do it faster. So Lynn, are you done? Both of the solution done, yeah? Preparing? Okay. Yeah, so you don't need those two beakers anymore. So just discard those things in the waste bottle and then bring the beaker. We need the beakers. So later on, you need to wash it with the tap water and then rinse it with the distilled water. And after we rinse it with the tap water or distilled water, we try as much now from the beakers, because we will be taking the solution that we just prepared in 100 milliliter, and that solution has been distilled, right? Sorry, diluted, 10 times diluted. So if my beaker, the beaker I'm washing now, because in that beaker I'm washing, I will take the solution in it and determine the pH of this. Yeah, so if there is water, it will dilute more. So you are not getting the correct. So that's what I'm saying, that try to discard the water as much as possible.
They look the same size, but the calibration mark is different.
Oh, one is a bit fatter, one is a bit thinner.
I can't actually see whether it's
yeah, inside, you have to see the inside. Done? You need to, I mean, have you rinsed it with the distilled water, this one? Enough. Just try to make sure that it touches everywhere or as much as possible, and then you can take the same water here because it is the rinsing, and then just discard the water. Done, Lynn? Done? What? Yeah. Hold on. How about here? Same? It's hammering because the air goes inside. We need to clear off the air from the pipe. Here you can use it now. Hopefully not. Maybe because the air may be trapped inside. Yeah. Hopefully it's okay. So what is your, yeah, this one? So have you rinsed it with the distilled water? Do faster. We just have 1 hour to finish, less than 1 hour actually.
How long do you think the second experiment will take?
Huh?
How long do you think the second experiment will take?
It will take long if you do not do it faster. Okay, so we start the pH meter, plug in the pH meter. Make sure that you do not. Huh?
Do you think you're going to take an extra hour?
I hope not, because today it is not for your first day anymore. So you are already, and you already have read the manual today, so hopefully it will not take. One thing, come here, I show you that the pH meter, have you used it before?
No.
So this is the pH meter, and I plugged in. This is the power button. There's the power button. This pH meter every day needs to be calibrated once. and our lab assistant, she's good. She did it for us, so we don't need to do it. So what we will do is, what is the important thing is this probe. This is the pH probe, and the liquid inside here, you can see inside that bottle, the small bottle, is the buffer actually. So do not peel that, throw it, and please be very careful in handling because the probe inside is very, very sensitive. And from inside, what is your beaker? The beaker that you want to just now wash. Yeah? Okay. Okay, so we will take the, let's say for ACL, we take the ACL first. Yeah. What we'll do is a little bit of it, little bit. Okay. Rinse it with this. And since it is very, very diluted ACL, so we can just, for the time being, or just leave it here, maybe. Okay, and then take this. Take maybe around 60 milliliter. More, 60, until 60 here, so that our probe will be, yeah, dipped inside. This is the thing we're going to do it. So we need to take off this bottle and like unscrew it somehow, like this also can. Okay, and then put it here. Yeah, put it here and dip it inside. Okay. Now I don't need to press anything. I can just leave both of these. Make sure that this is the conduction or the probe. That both probes are inside the solution. Is dipped. And after wait for maybe 10 seconds, it goes out. And for this case, I hope that you can see, it is 1.01 pH at 22.08 degrees. The current lab temperature is 22.8 or 23 degrees centigrade, we can say. And the pH, it will fluctuate. Not always it is stable, but around that we know that is around 1, or yeah, you can say it's 0.9798, around that. Okay. This is the pH of HCl. We are doing it. All right. One, Noor, help me to hold the phone, please. Once it is done, we will lift it here like that and leave the solution aside. Bring a empty container and wash it in this way, just like this. Don't need to force it, no need to do anything. Just rinse it gently. Then, can you help me to get some tissue paper from there? Because of its very sensitive nature and very sophisticated properties, we do not touch it or rub it or anything. Just gently wash it, and with the tissue paper, gently touch it like that, so that excess of water is taken away from here. Yeah, please do it for yourself. Okay, so now it is ready for my second thing, and that is CH3COOH. And you have to take this another beaker, rinse it. This is not ACL, yeah? Rinse it a little bit, take it and rinse it. Yeah. Put it there. Here. All right, and then take around 50 to 60 milliliter so that our probe will be dipped inside. Okay, good. Yes, and just like that. And press gently so that it goes down, both the probes. And we see that pH instantly jumps up to 2.8, or it will be a bit fluctuated, a little bit, less or more, but it is very evidently very big difference between these two. So probably we can consider it 2.75, probably should be okay after 10 seconds. Yeah, so 2.76, and the ready, the reading comes on the screen. Ready, that means we to take the pH from there, the reading. All right, so this is how we have done it for the, and same thing, you clean it. So show me that you clean it, take it out, and then rinse it. You can just rinse in there because we are going to discard this thing anyway. Yeah. Okay. Here, that one. Okay. And then wipe it a bit gently. I'm coming. No power switch? I'm coming. And once you have finished your job, please make sure that you put the solution in again, otherwise it will be dry. Remove this thing, and you need to screw these two things together. No, yes. Bring this, it will be a bit hard, so slowly bring it down. Yeah. Bring. More. Yeah. Now screw it. Okay, good. Thank you. So just leave it like that because we will need it later on. I'm going to see. Yeah. Oh, really? Hold on. Yeah. Vanessa, you done? Both? Good. Okay, it's already calibrated. This is a buffer solution so that the probe does not get dry and it maintains the neutral pH, or the pH is designated to some extent. Okay. First of all, rinse it a little bit, discard it, and then take the solution. Okay, so both of you have done, Vanessa and Noor, the first part, so you can proceed to the second part now. We need? Yeah. Sorry? Just leave it just like that, no problem. We'll need it, the pH meter, after some time, so. this case, because we will dip it inside, we just need to lift it a bit up. Yeah. Yeah, just throw it away. Let me check actually.
Because the rest, the concentration is not that low.
Oh, what is that? Yeah, for the second one, you just need 4 beakers. You can just discard all those things. Yeah, from the first experiment, you can just discard all those things. So you got the result already?
Yeah.
Okay. So just rinse it, wipe it with the, okay, let me get you some tissue. What is that? Oh, you have to close it fully. If you take water, just close it fully, otherwise it will be leaking. Be careful, don't come here, it is slippery. Done? Okay, so that you can just discard everything and then rinse it. First thing, you have to make sure that this pH meter is in the condition that is supposed to be. Rinse it first. Yeah. And then put into that solution the bottle, small bottle. Done? All right, so take 4 beakers. You have to take 4 beakers and take 25 milliliter of tap water. Not tap water, I think deionized water, right? 25 milliliter each.
So distilled water.
Yeah. We don't have deionized water, so we'll be using distilled water. Okay. So let me check first. Fume hood 1 sodium hydroxide. Not a small beaker. We'll be taking the 100 milliliter beaker should be okay, or 50 milliliters. Yeah, should be okay. Or 50 milliliter beaker will also be okay. Yeah, rinse it with water, distilled water. So now, for the part 2, take the beakers first, and we need to determine the pH of tap water and deionized water or distilled water for today in the lab. Okay. So take the. Have you taken the beaker? Okay. You need water. All right. So these are clean. Record the temperature for today's lab, yeah? It is already 22.8 or 23, around 23. So is it clean? So before we start the lab today, I mean, for the second experiment, what we will do is, somebody is here. What we will do is, we will determine the pH for the distilled water that we are using now today in the lab, and also the pH of the tap water. So just like that, let me bring the phone here. So this is the distilled water. I'm taking the pH for the distilled water, and the distilled water pH, it shows that it is around 4.5. It's not ready yet. .2. That means it's never Even it is water in the chemistry lab, don't trust, it is. You see? It is, the pH is well below 7. Quite acidic. Yeah, 4.38. Right? It is 4. Yeah, deionized water or distilled water, you can say. So it's 4.38. All right. So now I take, since it is deionized or distilled water, I don't need to rinse it anyway. So I take the pH for tap water. The tap water is much higher. It's going around 6 now. 6.09. We have to wait till it becomes ready so that we can collect. 6.23, in fact. So the tap water is almost towards 7, 6.64 now. It's not ready yet. It's increasing, and I think it will be around 6.8, 6.9, or maybe 7. Need to wait a bit till it reaches to the maximum and get ready, becomes ready for us to collect the reading. So Vanessa and Noor, are you doing the same? Are you taking the pH of the distilled water now? Okay, and record it, of course. It is increasing, increasing. Just wait a bit till it becomes ready. So let's see what Noor is doing here. Is it a distilled water or pH? I mean, this is distilled water. And your distilled water is 6.43. Okay, so you have to record the reading. 6.43. Yeah, just do it. And now you can take the tap water. I don't know. How much is yours? 5.44. 5.5 now. Wait a bit. It becomes till it becomes ready. So it is increasing for. My guess is it will be around 6.3 for you. Okay, let's see what Lane is having. Okay, 7.3 now for the tap water and still not ready. Yeah, no, it's 80. Yeah, it's 100 ml. But the thing is, these beakers are not very accurate. Okay, so if even it is 100, 100, we cannot say that it is exactly 100 because it is not accurate. It is written on the beaker. Is you can see, read that approximate value, and they don't even mention what is the tolerance, plus, minus. They don't say on the beaker. It's not written. Whereas you can see on the pipette or burette, it is written accurately that plus minus 0.05 milliliter. So it is very accurate. Huh? Oh, hold on. Yeah, sorry. Okay. Okay, but today only 3, and last we have 4 students. Today 3 came. Okay.
Any more class after this?
After one lab left, one more lab left.
I'll discuss it later, but this one will be distributed to them.
Okay. Okay. Thank you.
Can you acknowledge?
All right.
We were waiting for you in the lab just now.
Oh.
In the office.
Oh, I only left 9. Yeah. Thank you. So later on, you got the test kit. So I'll give it to you. Huh? Not now. Not now. After the lab. After the lab. Yeah. Okay. So. Yeah, you can. 25. Yeah. And I think, Lynn, you can just take 7 point. Yeah, it's ready now. 7.35 for your tap water. Okay. No, for her is tap water is 7.35, the pH, and probably you can try and take the distilled water once again, because your one was quite low than others. So just to get it right, to remove the confusion, let's see. Once again, we try how it becomes. So you do, I mean, in 4 test tube, I mean, 4 beakers you do, right? And each beaker you take 25 milliliter of water for the second part, and we have to do it faster because we have just 20 minutes to go, 25 minutes to go. Okay, let's see what Vanessa is doing. Take the same measuring cylinder for measuring the water. Don't take different measuring cylinder. These 2.
Already.
Another 2 you need.
Okay.
What are those? Oh, so for your distilled water 5.85, tap water is getting ready. It's very increasing very slowly and just only 0.01 at a time. So should be fast. Is it that cap is touching the water? Is it? The cap shouldn't touch. Lift it a bit up. Lift the cap a bit up.
What?
This cap, lift it a bit up so that it does not touch here. Okay.
So this ready later, we put it here.
Yeah, yeah. Oh, no, sorry. Deionized water, okay, we have taken. It's okay. We will just keep it somewhere here, the tap water. 7 point, for you, it's 7.7, let's say. It's getting. And the temperature is 22 degrees centigrade at the lab today. Okay, it's enough. Just take it. Okay, so you need to take these 2 beakers, right? Yeah. You can just discard the water and take 25 milliliter. Noor, have you taken all 25 in all 4 beakers? Huh? Okay. So if you have taken water in all 4 beakers, 25 milliliter each water, you don't need to bring those 0.1 molar sodium hydroxide, sodium acetate here. I put droppers in that fume hood 5 and 6. So you go there, take your beaker, go there, take 5 drops of each of those in 1 beaker each beaker, and then come here and measure the pH. After you have measured the pH, take out the probe and then rinse the probe with distilled water and go for the next beaker. So for you now, 1, 2, 3, 4. So this is 1 for 1. Which one is 1? Okay, this is 1. So for 1, you need to add 5 drops of 0.1 molar HCl, and 0.1 molar HCl is in fume hood 6, right? So you have to go to, with this, go to take this, go to fume hood 6, and I left the big droppers there. Okay, let's go, I show you. The droppers, you have to just add 5 drops of HCl there. Yes, this is the HCl, and use this. I already rinsed it for you, so just take 5 drops, okay, from here. Two, 3, 4, 5. Yep. Swirl a bit. Yeah, enough. Good. So now take the pH. Determine the pH there. And the pH is 3.4 reduces. It will reduce more because we have added HCl to it. 3.4, 3.38, but it is not reducing very drastically, so it's getting towards the stable thing. And I'm hoping that it will stop soon. .4. So I hope it will be 3.30 around it. It will be, stable. Yeah, it's not changing anymore. Yeah, it's ready. So you just take this reading, 3.33. After adding 3.33, yes. So the same way you do, yeah? Now take the second beaker, go and add 0.1 molar sodium hydroxide, which will be in the fume hood 5. And okay, no, you have to take it out from here, rinse the probe with distilled water. Where is the distilled water? Take the distilled water from there. Yeah. Yeah. Rinse it here inside, just rinse. Yeah, just, we are not going to use this anymore. Yeah. So just leave it like that and then bring it, and you should, okay, you just go bring it, second one. And then you can, later you can throw all together. Yeah, Vanessa, you were taking something?
Both probes have to be touching, right?
Yeah. Really?
Okay.
What is this, the solution? Oh. You cannot just leave it like that?
Doesn't touch.
Oh, okay. Hold on. Or maybe you can just leave it this way so it doesn't fall. Yeah, it's touching now. I think it is getting stable. 3.21 for you. Yeah, ready. Okay, now go for the second one with sodium hydroxide, the same way. But you have to rinse the probes, okay? You have to rinse the probe before you go, otherwise you'll forget later on. All right, so do it. And where do I put my phone? The students, are you watching this or? Okay. Anyway, I think nobody is watching, but anyway. Yeah, you can. Need to do faster. We have only 15 minutes to go. So for Noor, yeah? Sorry? Yeah. Just cancel those all reading. Yes. And then you put it there, 3.3. Yeah. Just rinse your thing here also, because we are going to throw it anyway. Okay, enough. Just go and bring the second one faster. Sodium hydroxide, 5 drops. I just leave it to Noor's plates so that everybody can see, hopefully. Where do I put it? Yeah, should be good. The electrode touching it, the metal one? At least to touch. No need to be too much. Oh, okay. This is why we do not allow this type of this one drop of acid falls on your knee. It's not touching yet. You have to make sure that both of the probe and this electrode touches. Now it's touching, and it has to be immersed inside, okay? Yeah. This is ethanoic acid. It will be around this figure. Huh? What is that? Sodium hydroxide.
Sodium hydroxide.
Sorry? Ethanoic acid. That will be. Yeah, 56.
tap water. That's 3.3. Yeah, should be okay. It's not changing much. Buffer. After that, we will here we and for the buffer solution, we get 250 milliliter per day. So take the 250 milliliter beaker, wash it with the distilled water, tap water first, and then rinse it with the distilled water, right? And then add rinse, and right. Of and then take 50 milliliter of yeah. So this here is 50 milliliter of sodium ethanoate, which is sodium acetate as well, and then 50 milliliter of acetic acid, which is ethanoic or acetic acid, same thing. So these are in fuel mode 5 and fuel mode 6. So you get 50 milliliter in this beaker and then 50 milliliter in this beaker, both together mix it, and then that will be a buffer. Right. So Hello, can you hear me?
Yes.
Hello, can you hear me, Eric?
Yes.
Oh, yeah.
I can hear
Okay.
you.
Thank you. Erlin, Brenda, Bilal, all three of us with us. The rest are not here. Yeah, what?
The rest left.
Yeah. What did you ask? Have you taken the 50 milliliter of one?
So yes,
Yeah, put it here. Put in the beaker.
so no need to label, right?
No need, because this is only the buffer solution that you have. Let me show you to your friends. Eric is waiting there. Okay. Vanessa is preparing the buffer solution. She just put 50 milliliter of what? Sodium acetate she put, and then she will put another what? Yep. So that is in your fume hood where?
Use the same one, right?
Same one, yeah, better. Because of intolerance. Sorry, what is that called? I forgot the word in there. I'm hungry.
Who is hungry?
You have taken already what?
What?
You have taken what?
Sodium acetate.
Okay, so that's what. Sorry, take the beaker also and go there. Also, just take or yeah, you just take it. Sodium acetate. So you have to take now acetic acid.
Ethanoic acid.
Yeah, same thing. Ethanoic acid and acetic acid is the same thing. Go. Oh, okay. Take it. Bring your eyes to the level. Yes. 50 milliliters should, yeah. Is it 0.1 molar?
Yeah.
Hey, wait. No, wait.
No, it's 1.0. According to the procedure.
Really?
Yeah.
Wait. Oh, both are 1 molar. Yeah. Both are 1 molar. Okay. Lynn, are you done? Waiting for this. Yes, you should use the same cylinder. Have you washed it? Okay, good. Why don't you? Oh, the light actually not working. Okay. Add. Yeah, just add. Yes. Oh. There are few more drops. Yes. See, 4 drops came out. So now your buffer solution is prepared. You have to take the reading first of the pH from here. .3, is it? 5, actually it is 5. It's going to be reduced more. We should use a glass rod only to stir, not new, but do not use this thing to stir it, never. It should be 4.7 around. It's reducing 0.01 at a time, so it should be okay. I think it is getting there soon. Hmm?
What do I do first?
Yeah, you need to record here. This is the buffer.
Then?
Yeah, so you have to record it here.
So later the buffer solution
we need to divide into 4 beakers, each 25 milliliter each. Okay, and then do the same thing. In one beaker, we add 0.1 molar HCl, see how the increases or decreases. Another one, I add another beaker, take 25 milliliter, and then add 0.1 molar sodium hydroxide, see how it changes. Same thing. Only the thing is, we'll be dividing this 100 milliliter into 4 different beakers. So you have to have 4 beakers. So by the time it gets ready, you can prepare 4 beakers, 1, 2, 3, 4, yes. Oh, 4.82, yeah? Oh, okay. You can. Ten minutes. Don't gather everyone same place at the same time.
mixing the 100 together, then we put 25.
25 to each. Have you washed?
Yeah.
So you have to prepare 1, 2, 3, 4, or I don't know, how do you label it? You label it. So which one you are taking now? It's acetic acid, yeah? Since we don't have much time, I think we can just take 4.40. This is reducing 0.01 after 2 seconds each time, so I think it will be ready soon. Yeah, so now you can take the pH of this buffer.
So
Yeah.
we measure all the 25.
No, just one is same, right? Same thing, so you don't need to. Just you need to do is, have you measured the pH for the buffer?
Not the 100.
Okay, so you don't need to do then 25 again. You just need to add the same way. One beaker you add 0.1 molar HCl, another beaker you sodium hydroxide. Same, just now what I do is just the same. We just want to see the contrast. Got any result from the buffer? Oh, so you got one. It's 4.81. Prepared the buffer already? Okay. Put it on the table and then see how.
Guys, you can talk. Everyone can hear now my battery. I think we'll be doing 1, 2, 3, 4. So just need to add 5 drops. Hydroxide. You are taking one. Yeah. Ready? 4.67. Number 1. Yeah, feels more up. fix it, and put the probe inside there. Another 2 minutes for us to do finish. And of course, we have to rinse, clean, clear everything, and sanitize before you move on. Yeah. Figures. It's
That's
yeah, figures here. Let's do it, and all right, so it is done, guys, and I think I'll stop recording, and my battery is quite low. Okay, so you have to submit the lab report by next week, and your test on is a busy week coming next week. I never stop reminding things. That's why I put the announcement every week so that you know what you're supposed to do. And another thing, what I was saying. So for all of your friends, they are doing these things. You see that the final pH for the buffer is almost similar to each other: 4.67, 4.68, 4.64. Which is in contrast to the previous one is much different. So you have to discuss this thing in the discussion, why, how, what is happening actually, and what is the theories, all those things. So online guys, do you have any questions? Anyone? If no question, then I will stop it now here. I'll see you tomorrow for the tutorial. All right. Thank you, Bilal, too. Yeah. All the best.
Thank you,
Bye-bye.
sir.
You're welcome.